All right, today we're going to get into the second half of 9.2. If you remember the first part, we looked at the real number system and introduced irrational numbers and the concept of real numbers. Our learning target today, we identified real numbers in 9.1. We're going to compare them today in 9.2 day one, and we're going to compare them today in the second half. And then we're also going to solve equations using square roots. All right, so I just want to refresh our square roots, right? So square root of 9, this square root symbol as itself is implied to be positive. So if I just have the square root of 9, it's going to be 3 because 3 times 3 is 9. If the negative's on the outside, right, the negative square root of 9 would be negative 3 because negative 3 times negative 3 is also positive 9. Remember, this one is not real. The negative underneath, I can't multiply the same thing together to get a negative number, right? In order to get a negative 9, one of them would have to be a negative and the other positive. So that's not possible because square root means something times itself. And where we're taking that today is when we solve equations, right? I want to find when I square a number that it's equal to 9. And we can see over here there's two possibilities, right? And we're going to use inverse operations, right? So when I square root both sides, right, I'm have to find the value of x. When I square it, it's equal to 9. And that would be both 3 and negative 3, right? If we think about that original equation, if I did 3 squared, I get 9. And if I did negative 3 squared, I also get positive 9. So when we solve today, we're going to actually be finding two solutions to our equation. All right, let's start by comparing numbers, right? And the easiest way to compare them is if they're in the same form. And probably the easiest form to use is going to be decimal. So if you use your calculator and do the square root of 34, it should tell you it's 5.830, right? 9 dot 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 keeps going. And if I did 5 and 3/8 on my calculator, right? If I did to find this decimal, I just do 3 divided by 8, and I'm going to get 375. So in doing that, I can see that 5.8 is bigger than the 5.3. So the square root of 34 is greater than 5 and 3/8. Now, if we look at the next one, 6 and 4/5, if I did 4 divided by 5 on my calculator, I get 6.8. And if I do the square root of 48, right, and we should be able to approximate that, right? Square root of 49 is 7, so it's going to be close to 7. If I do it on my calculator, it's 6.928, right? So the 6.9 is greater. That means the square root of 48 is greater than 6 and 4/5, right? Now, in number 3, these two look like different numbers, different values, right? But we know the square root of 84, square root of 64 is 8, and then 8 is just 8. So these two are actually equal to one another, all right? So when we compare, we're just going to put them in decimal form to compare them. All right, same with ordering from least to greatest, right? I want to get them all in the same form. I want to get them in decimal form. So I know that this is 4.5. If I did the square root of 17, right, it's really close to the square root of 16, so it's going to be just a little bit bigger. So then this would be, if we type that in, it's going to be 4.1. If you want to do a couple more, 2, 3. 4.4 with the bar over it is just 4.444, right, repeating, and then this is just 4. So my smallest value is going to be square root of 16. Next in line is the 4.123, right, which came from square root of 17. and then 4.44, and then last, the greatest number there is going to be 4.5, right? So we can just turn those into decimals and compare them, right? Similar here, 3.777. 3 3/5 is going to be 3.6. Square root of 13 is going to be 3.605, right? Which is a little bit bigger than 3.6, right? And then 10 thirds is going to be 3.3 repeating, right? So if we order those from the smallest, right, 3.3, so that's 10 over 3. Next is going to be the 3.6, which is 3 3/5. Next is 3.605, which was square root of 13. And then last is 3.7 repeating. So we can just order them from least to greatest by comparing their decimal values. All right. And where we're leading here is to being able to solve x squared or quadratic. Those are called quadratic equations. All right. And I'm going to start with a review of solving a linear equation, right? The y equals mx plus b. So we're finding 2 times something plus 1 equals 7. And what we do is we use inverse operations to do that. So if I start here, right, the opposite of plus is going to be minus. And I have to do it to both sides. So that would cancel out. I'd have 2x equals 6, right? So 2 times something is 6. The inverse of multiplication is division. And we end up with x equals 3. Now, when we solve an x squared, right, it's something times itself has to equal 16, right? And I have to remember that we have both a negative and a positive value for square roots. So to solve this, right, the inverse of squaring something is to square root it. And here's what I have to remember. I have to use the positive square root of 16 to get 4, and I also have to remember the negative root of 16 is equal to negative 4. So these are my 2 solutions for that, right? And sometimes you'll see that written as plus and minus 4. That means both positive 4 and negative 4 are my solutions. All right, and I'm going to show you on the graph why that is. So I'm going to start with the first one, 2x plus 1. So if I do y equals 2x plus 1, plus, there we go, 2x plus 1. And I'm trying to find when does that equal 7. So I want to find the y value where it's equal to 7. So if I scroll, right, and I can just pick a point on the line, I'm trying to find when it's equal to 7. Right, and I can see right there 3, 7. So when x is 3, that y value is 7. Here's another thing you could do to solve that. You could say, well, I want to find when y equals 7, right? And we can find this intersection right here. So there's only one spot on that line where it's equal to 7. However, if I do x squared, right, and what were we trying to find? When it's equal to 16. So if I come up here, right, I see that it's equal to 16 both here at positive 4, and it's also equal to 16 at negative 4, right? And we can use the line again, y equals 16, and see that it crosses twice, both at a negative value and a positive value. All right, so let's look at solving these x squared equations, right? When it's a perfect square, it's nice, right? So I would square root, and I know that both 8 and negative 8 would be my solutions, because 8 times 8 is 64, and negative 8 times negative 8 is also 64. So here, when we square root to solve, we get x is going to be equal to both positive 5 and negative 5. So essentially what you have to remember is to get your positive answer and your negative answer, or just remember to do a plus and minus in your solution. Now, when it's not a perfect square, right, where I recognize it and I square root, I'm going to have to use my calculator. And I should know that the square root of 74, right, it's between 64 and it's 81, right? That'd be 9. So it's between 8 and 9. So it should be 8 point something. So if I take the square root of 74, my calculator tells me 8.60, right? And we can just do to the nearest tenth. So 8.6. I have to remember that it's also negative 8.6, or type in my calculator the negative square root of 74 to get that second answer. All right. So last one here. Again, not a perfect square, but I know that 85 is a little bit bigger than 81, right? Square root of 81 is 9, so it's going to be 9 point something. And if I take the square root of 85, I get 9.2, right? It's 9.219, but we'll just go to the nearest 10. And I also have to remember that it's negative 9.2, right? Because I have to do the negative square root of 85 as well. All right, so your practice for today, the following problems on page 444, 33 to 38, that's comparing less than, greater than, or equal to. 40 and 41 will be ordering from least to greatest, and then 45 to 53 is solving. Hope you have a great day. If you have questions, stop down and see me.